In this lesson, we're going to study one other algebraic way of solving systems of equations. Now, I typically call this the elimination method because when you carry out the addition process, one of the variables will be eliminated, and we have to get to a point where we can eliminate it. You will also hear this method referred to as the addition method, and you may also hear linear combinations, okay? So if you were scrounging the internet looking for other like videos or some practice problems, you could use the word elimination. Sometimes you'll see the addition and subtraction because you can approach it that way as well. What I'm going to do is give you the idea behind it, like why it works, and then we'll talk about like what the steps are, and then work through a couple example problems. And then the resource that I'm using to develop these videos has a pretty good summary of the different methods and stuff for solving systems of equations. So I want to illustrate something here, and this is going to seem really basic, but I want the why behind this to be pretty clear. I think most of you would agree that this is a true statement. 3 equals 3. Okay, well, all of you should agree, and if you disagree, I don't understand why. But 3 is equal to 3. Now, it is also true that 5 is equal to 5. Okay? Now, here's the idea that's going to be in play here. If I take 2 true statements and I add everything on the left side of the equal sign, and then I add everything on the right side of the equal sign, I get another true statement. Because what bothered me when I was in high school and I was studying this is like substitution made sense to me. It felt logical. It felt like it made sense. Where elimination, I don't know, it felt a little bit like magic. And so I'd like to start off by establishing the idea that you can add the left side of equations together and add the right side of equations together, and you will still get like a true statement. And it works if you add variables. So if you had x equals 4, and then you have, I don't know, y equals 3, okay? Then you could add them going down, and x plus y would be equal to 7. And so that principle holds. Okay, so that's pretty much what we're going to be doing here. We're going to be adding these equations going down, and we're going to add them in a particular way. All right, so the first step, I'm going to put the steps up here, and we'll talk through what the steps are, and then we'll apply them in an example problem. Okay, so I typed them up. I haven't been doing like too much typing in these videos, just like the title. And what we're going to do is talk through what these steps are, and in an appropriate color, I'm just going to show you what it looks like or what we mean by it. So the first step you need to do, and I don't know why like the equations is like the editor like automatically capitalized the word equations. I don't know why. It's kind of weird. But anyway, moving on. So we're going to go through and just kind of talk about what these steps mean. Okay. And so I'm going to pick a problem that needs to have us do all of these steps. So, let's see what we've got. These are all lined up. Okay. So, suppose you were looking at a system that looked like this. So you have 5x plus 2y equals 7. And then the next system or next equation was 3x equals 13 plus y. And the first thing you really want to notice is that the variables are not lined up the right way. So you want the variables and the equal sign lined up. They don't have to be in a particular order, but most of the time it's going to be in standard form. You're going to have 5x or like an x plus a y equals the constant, but they really can be lined up in any order. And when I teach this in my Algebra 2 classes, I'll typically follow what my students are doing, like whatever they tell me to do is the way that I'll approach the problem, but I'll try to do one where we have it like in x equals constant y or something, so that's in a different order, because there's nothing about that step that says it has to be in a specific order, only that they have to line up. And right now we've got our x's lined up, then we have like the y lined up with an equal sign, we have a constant lined up with an equal sign, and we have the 7 lined up with the y, and so they're not lined up. So we'll go ahead and we'll do this kind of like the traditional way, which is put them both in standard form. So that first one is already in standard form. And then what we need to do on the bottom of the equation is we need to subtract y from both sides, because we need the y on the left side of the equal sign. And so we'll go ahead and subtract the y, and then that's going to give us 3x minus y equals 13. And now these line up. So if you follow, we've got like 5x plus 3x, y, and negative y. The equals are lined up, and the 13 and the 7 are lined up. And so that's the first step. Now, a lot of times when you're first learning how to do these, they will already be lined up. And in fact, I was looking at like my bank of problems, and they were already all lined up. And so a lot of times you don't have to do that first step. It's just if they aren't lined up, you do have to kind of front load with that step to begin with. So just be aware of that. And that brings us to the second step, which we will be doing in red here. And that is what I call the thinking step, okay? And what you have to do here is you actually have to study the system. You have to make a decision about the best way to do it. And it says multiply one or both equations by an appropriate number. So they're like, well, what's an appropriate number? You've got to figure that out. You've got to figure out what the appropriate number is. And here's what you're looking for: to get coefficients that are opposites. So remember that opposites would be like 4 and negative 4, okay, are opposites. So we would like to see something like 5 and negative 5, or 3 and negative 3, 2 and negative 2, negative 1 and 1. You can go like bigger. You could go with like 15 and negative 15 there. Okay, but you've got to think through it, and you have to just make a decision. And there are different places, like different decisions that you can make. So I would typically ask my students, you can try to eliminate X, or you can try to eliminate Y. Which one do you want to eliminate? And there's no right or wrong answer, but there is often a better answer. And in this case, the better answer is to eliminate the Y. And here's why. You're looking for opposites. You already have opposite signs, so that's going to be really good. Also, you have a 2 and a 1, which are smaller numbers than the 5 and the 3, which mean that you're probably going to have like an easier time of it. Now, what we want to have here is a negative 2, okay? And it would be awesome if you could just change it to a negative 2. But you can't. That's voodoo, okay? That's like magic, okay? But if we want to get a negative 2 there, there are some things that we can do to get us there in an algebraically sound way. And what we're going to do is multiply one or both of the equations. In this case, we only need to multiply 1. If I take negative 1 and I multiply that by 2, I will get the negative 2 that I want. Here's the kicker. You can't just multiply one piece of the equation by a 2. You've got to multiply both sides in order to keep it balanced. And if you're going to multiply everything on the left, you have to multiply everything on the right. And so what we're going to do is take the left side and multiply it by 2, and we're going to take that right side and multiply it by 2. I often will use a shorthand for this that is maybe kind of dodgy notation, but just because I think it's a little bit messy to do it that way, I'll do something like this, where I'll just put parentheses around the whole thing and just put the 2 out there. Probably you shouldn't have like an equal sign in the middle of your parentheses. It's just cleaner looking. That's really all I'm doing there. In this case, we're not needing to multiply the top equation. We can just multiply the bottom equation. So I'm going to go ahead and copy the top equation. And then when I write the bottom one, I'm going to multiply that 2 through. So I'm going to have 6x. 2 times negative 1 is going to give me that negative 2. And then 2 times 13 is 26. And that brings us to the purple step. which is add the equations so that one variable is eliminated. Now, if I go back to my original problem, okay, so we'll kind of get rid of that. If I go back to the original problem, if I try to add it as is, I would get 8x plus 1y equals 20, which is wonderful, but totally useless. Like I still have an x and I still have a y, and it just doesn't get me where I want to go. Now that I've done this step here, okay, now when I add them, we are going to eliminate one variable. So 5x plus 6x is 11x. 2y plus minus 2y or plus negative 2y is 0, okay, and that's why they cancel out. And then 7 plus 26 is 33. And then we would solve that, and we get x is equal to 3. Okay, so add the equation so that one variable is eliminated, and I should probably say and solve it. It'll be a one-step equation if you do that correctly. You're just going to have a division to do. And then our green step there is substitute your answer to number 3 into either original equation in order to find the other variable, or eliminate again with the other variable, and I'll show you what I mean by that. But I'm going to take my x is equal to 3, and I don't know. I like this one because like the 7 is smaller, but the 3 and the 1, it's probably the same. We'll just do the top equation. Plus 2y equals 7. So 15 plus 2y equals 7. Subtract your 15 from both sides. That's a 15. That is a 15, boys and girls. Obviously, that's a 15. Sorry about that. 2y equals negative 8. Divide by 2. And x is equal, or y is equal to negative 4. Sorry about the spacing on that. It's like kind of terrible for the spacing. Okay, and you could plug it into, the other one might have been a little bit nicer to do. Yeah, but we would end up with y is equal to negative 4 either way. And that's pretty much the way this method works. So we're going to work through a couple more examples just so you can see that hashed out. And what I'll do in the last example is instead of substituting in, I'll work the elimination the other way, just so you can see what I mean by that. Because some students actually prefer that. Okay, so here's one. And so we have 4x plus 3y equals 1 and 2x minus 3y equals 1. This was actually, it was a problem just like this where I discovered photomath for the first time because my students were doing this a really, really weird way. Photomath, and it still does it because I just tried it like as of the recording of this, I tried it like a couple weeks ago on my phone. Photomath does this a bizarre way, okay? Don't trust the apps. The apps do not do these problems the best possible way. You can use them to check your work, like check your answers, that kind of thing. Maybe get you over the hump if you get stymied on something, but if they're doing like bogus stuff, it's probably algebraically sound, but it's also not anything a human would want to do. So when I look at this, if you notice it, the 3y and the negative 3y, well, first of all the variables are already lined up. Okay, everything looks good. You have your x's, your y's, your equals, and your 1's. Good. And you also already have your opposites lined up. You have a positive 3 and a negative 3. So if I add those, that's going to add up to 0 right away. So 4x plus 2x is 6x. Those guys cancel out, and I'm left with 1 plus 1 is 2. Divide both sides by 6, and then 2/6 simplifies to 1/3. And then I actually am going to change plans midway through this video. Because if you look back here, once you get your first variable, you can substitute into either equation, or you can solve for the eliminate again with the other variable. And pretty much in this particular problem, I don't want to work with the 1/3. I don't want to work with the fraction there. And so I'm going to avoid it. And what I'm going to do is kind of reboot the problem. And the first way that we did it, we eliminated the y's. Okay. So the y's canceled out. This way, I'm going to go and eliminate the x's. So if I wanted to add them to eliminate the x's, 4 and -4 would be what I want. But I can't magically put a -4 there. I can get a -4 if I multiply that equation by a -2. Just remember that you got to multiply everything by a -2. So that's going to end up being, we're not touching the top equation. -2 times 2 is going to give us the -4. -2 times -3 is +6. And then -2 times 1 is -2. Now when I add them, now the x's are going to drop out. And I'm going to get 3y plus 6y is 9y. And 1 plus -2 is -1. Divide both sides by 9. And I get y is -1/9. And what that enabled me to do is it enabled me to avoid having to plug in that 1/3 because I didn't really want to do it anyway. I could have taken the 1/3 and put it in for the x in either position and then like subtract it, and I would have 1 minus the fraction, and then I would have to take that fraction and divide it by like the 3 or the -3. I just don't want to tangle with, it's just messy. And so what you can do is you can eliminate again with the other variable, and you just kind of reboot the problem. I'm going to do one more that's going to require us to multiply both of the equations. So let's take a look at this one. Let's do 5u plus 6v equals 14, and 3u plus 5v equals 7. Okay, so this one, neither, like you don't have this nice deal where you could just multiply one equation and get, them to line up. 6 is not a multiple of 5, and 5 is not a multiple of 3. Okay, so there's actually, what you want to do here is you want the least common multiple, but I'm also aware that a lot of students confuse least common multiple with greatest common factor, and we haven't really talked about that in this video series, so I don't really want to go there right now. I also know that even if you do understand what they are, you might not be good at finding them. So there is actually something you can do. It is 100% foolproof. It will work every time. The only drawback is that it might introduce numbers that are bigger than what you really want to work with, but it'll work. Let's say you make the decision that you want to eliminate the u, okay? What you can do is take the top equation and multiply it by the bottom coefficient. So in this case, since we're looking at the u's, we're going to multiply the top equation by 3. And then take the bottom equation and multiply it by the top coefficient. And that will work, which in this case was a 5. That'll work all the time because you're guaranteed to get the same number because you're just switching the numbers. So 3 times 5 is the same as 5 times 3. Now, there's one other hiccup. In order to get these to cancel out, as they're written right now, both of them are positive 15. One of them has to be a negative 15. It doesn't matter which one is negative, so just like slap your negative in front of one of them. Okay, and again, like I said in the last video, if you and your neighbor are doing all of these problems, making exactly the same decisions at every single decision point, that is going to be suspicious. All right, I had a student ask me a couple weeks ago, what is that? It's like, so an arrow means something in math, and so I didn't want to use an arrow, and you don't want to use an equal sign. So it's like an arrow, but with like a double bar on it. All right, let's go ahead and multiply that through. So we end up with 15u plus 18v equals 30 plus 12 is 42. On the bottom, we have negative 15u minus 25v equals negative 35. And now we're set for those u's to drop out. 18 minus 25, I believe, is negative 7. And 42 minus 35, I believe, is positive 7. Divide both sides by negative 7, and v is equal to negative 1. And then you are welcome to plug the v in. So we could do 3u plus 5 times negative 1 equals 7. 3u minus 5 equals 7. Add your 5 to both sides. 3u equals 12, divide both sides by 3, and u is equal to 4. I do want to do one more thing though. That's typically how I would do it. A -1 isn't too bad to plug in, but just because I want to really emphasize that this idea of just switching the coefficients around, and to show you that you can just do the elimination process twice if you want to, is I'm going to work this out just making a different decision. So let's say instead of saying, oh, I'd like to eliminate the u's, you said, I would like to eliminate the v's. And so what we're going to do is switch those coefficients. So if I want to eliminate the v's, I'm going to take the top equation and multiply it by the bottom coefficient, which is 5. And I'm going to take the bottom equation and multiply it by the top coefficient, which is 6. Now it happens in this particular problem that you are getting the least common multiple, but like other times, like you just might be missing something. Like if you had like a 4 and a 6, the least common multiple is 12, but you would be working with the 24, which should be fine. Then we need to make one of them negative, and I'm going to go make the bottom one negative again. And again, notice all the different places where you have a decision to make. Don't make all the same decisions as your neighbor. 5 times 5 is 25, 5 times 6 is 30, and 5 times 14 is 50 plus 20, which is 70. On the bottom, we have negative 18u minus 30v equals negative 42. And now, when we add them, the v's are going to be eliminated. 25 minus 18 is 7u. And then we have 70 minus 42, so 70 minus 30 is, or 70 minus 40 is 30, and then we're going to subtract 2 more, which is going to give us 28, and then divide both sides by 7. It's totally up to you if you would like to take the first value and plug it in, or if you'd like to just run the elimination a second time. Either way is totally valid. They should both get you to your answer. And if you run into something like a nasty little fraction, then you probably want to do the elimination again. All right, so this lesson ran a little bit long. I'm going to get those practice problems up on the screen, and then you get to try out this method on your own. Okay. 3x minus 5y equals 1. 2x plus 5y, that is why I read it out loud right there, boys and girls, plus 5y equals 9. Second one, x plus 7y equals 12, and 3x minus 5y equals 10. 3x plus 2y equals 10, and 2x plus 5y equals 3. 3a plus 3b equals 7. 3a plus 5b equals 3, and 10m plus 16n equals 140, and 5m equals 8n plus 60. Pause the video, work them out, and then as always, unpause the video to check your work. All right, here we go. As with every review, if you need to pause the video and just look over your work, look over my work, bearing in mind that there is a decent chance that your work and my work are not going to be the same, okay? Now, for this first one, probably it is. So hopefully you recognize for the first one that the negative 5y and the 5y were already lined up. And so that's ready to do your addition. So we have 5x equals 10, divide both sides by 5, we get x equals 2. I plugged it into the top equation. You might have plugged it into the bottom equation. Totally okay. We get 3 times 2 is 6. Subtract 6 from both sides. Negative 5y equals negative 5. And we should get y is equal to 1. If you plugged it into the bottom one, you would have 4 plus 5y. Subtract 4 from both sides. So you'd have 5y equals 5. And then divide both sides by 5 to get y equals 1. Okay? Second one, I decided to eliminate the x's because that was the easier one, and all I had to do was multiply the top equation by 3, negative 3. You do not have to do it that way. So that gave me negative 3x minus 21y equals negative 36. I did not alter the bottom equation. The x's cancel out. They are eliminated. Negative 21 minus 5 or plus negative 5 is negative 26. And then negative 36 plus 10 is also negative 26, which means that y is equal to 1. I plugged the 1 into the top equation. And so I have x plus 7 equals 12, subtract 7 from both sides, and we get x is equal to 5. So y is equal to 1, x is equal to 5. As we're going over these, though, I do want you to notice how many different ways there are to do it, how many decision points there are in the problems. For this one, I went in a different tack, and I know one of the ways that I intend to present these videos to my students is to have them do their work on one side of the page and for me to do and then to copy my work on the other side of the page. I'm not necessarily going to do that all the time, but it's one of the things that I have in mind. And so by doing something like this, I'm kind of throwing you for a cool curveball because the chances that you're going to decide to do the same thing, really, really small. So in this top part, I decided to eliminate the x's. So I switched my coefficients around. I had to make one of them negative, okay? You don't always have to do that, but when they're both positive or both negative, you do. Multiplied them going across so that my x's would eliminate. I have a negative 6x and a positive 6x. Now notice the decisions. First, I had to decide to eliminate x. Then I had to decide which of the numbers was going to be negative, okay? So I know I keep reiterating this, but when you're working with your buddy, you and your buddy should not realistically be making all of the same decisions in every single spot, in every single problem. Like at some point, you're going to decide, I want to eliminate the y instead, or I'm going to make the 3 negative instead of the 2 negative. Okay, solving this for y, I ended up with y equals negative 1. Okay, so we added going down, we get 11y equals negative 11. Divide both sides by 11, we get y is equal to negative 1. Here's a little curveball. Instead of taking the negative 1 and plugging it in, which I could do, I decided we'll go through the process again. This time I'm going to eliminate the y's. So I recopied the system. This time I switched the 5 and the 2, and I decided to make the bottom one negative. Multiplied going across, added going down, and I get x is equal to 4 without having to do the substitution in. All right, you can do that. Of course, if you don't have me for a teacher, all right, and you're just watching these videos, you need to follow whatever directions your teacher gives you. Okay, so your teacher might tell you to do something else. If your teacher says, where did you learn how to do that? You can link them to this video. Okay, that's totally fine. I often wonder the same thing when my students do stuff that I didn't teach them. But it is an option for you there. On the fourth one, I decided to eliminate the A's. The A's are the better choice. You have the matching variables, except they're both positive. So you have two options there. Some people will just subtract. They'll say, I'm just going to subtract these equations instead of adding them. But remember, the definition of subtraction means to add the opposite. So what we're doing here is we're multiplying by negative 1 to get the opposite, and then we're adding. But a lot of people will just go 3a minus 3a, 3b minus 5b, 7 minus 3. Okay, and that will bring you right down there, and you don't have to go through the multiplication step. Totally okay to do. Don't really want to get there in this video because it's already running kind of long. We end up with negative 2b equals 4. Divide by negative 2. B is equal to negative 2. I opted to plug it into the bottom equation, and there's really no rhyme or reason for which one I pick unless one looks much easier. 3a minus 10 equals 3a minus 10 equals 3. Add the 10. Divide by 3. Kind of thankful that you run into the fraction at the end and not at the beginning, because then the substitution becomes yuckier and you might want to do that double elimination. Last one, I decided, first thing you need to do is you need to rearrange the order there. So the very first thing you need to do on this one is subtract the 8n. You could also subtract the 16n and move it to the other side, like of the equal sign on the top one. Usually people won't do that, but you can if you tried to do that. That's fine. Then I decided to eliminate the n, and I chose that because I already had the opposite signs. Okay, you could go with the m and multiply by negative 2. So if you did that, you don't erase anything. Like, that's totally okay to do. Kept the top equation the same, multiplied the bottom one, ended up with m is equal to 13, which I then plugged into my rearranged version of the bottom equation. I don't actually know why I did that. Ended up with 65 minus 8n equals 60. Subtract 65 from both sides. Divide both sides by negative 8. and I ended up with n is equal to 5/8. Full disclosure, I did make a mistake when I did that the first time. It was a silly mistake. I did 60 minus 65 was equal to negative 65. Like, it was just like a little copy me thing. And I almost wish like I could do that during the video, except that I kind of look like an idiot when I do that. But I do want to point out that like teachers make those mistakes. And so it didn't like in the last video, it didn't feel right. So what I did was I tried plugging it into the other equation over here, and I got the 5/8, and those two numbers should match. And so basically I knew I had to go back over here and rework it and find my mistake.